talking about networks or something.
Hello, good morning. First of all, I think we should give another round of applause to the organizers for North Bay Python for putting on this incredible event year after year after year. So like Chris mentioned, I, for the past couple of years, have had a tendency to do things in the category of stunt talks. 2 years ago, I turned this conference into a public committee meeting for my talk, Automate Your City Data with Python. Last year, I took us all to space with planets full of Python talking about ActivityPub. And let's see, under a month ago, I had this thought. Aha, I can figure out a way for Meshtastic to do a stunt talk based on either Mulan or Lord of the Rings. And then I actually gave that some thought and realized that if I did that, I was going to alienate at least half of the audience with either of these choices. And so I decided to not do that. So my name is Philip James. I have been using Python for many years, both professionally and as a hobby and for side projects. A couple things that I do right now. This is a little bit meta. This is a screenshot of me giving a talk, referencing me giving a talk at North Bay Python. Couple things that I do. I am the kind of founder of Civic Band, which is a continuation of that Automate Your Civic Data with Python talk that I gave a number of years ago. And I'm also the CEO of CrowdAlert, which is a security tooling company based in the Bay Area. Today, we're going to be talking about Meshtastic, mesh networking with Python, but I want to start by talking about network topology. How many people recognize this image? Great, okay, that's a decent number of you, so I'll explain it. I think a lot of people, when they think about the internet, have an image something like this in their heads. This is from, you can maybe see down the bottom there, from 1971. This is the map of what DARPA, the first internet, was back in 1971. It was mostly military institutions and universities, and this was the internet. And you might notice that there's a lot of direct connections there, but it's kind of sort of a mesh. And if you have stayed up to date on network topology, you might think it looks something more like this. This is a map of all the underseas cables that kind of span the globe. And there are a lot of them, and you might say, okay, well, this also kind of looks like a mesh. So maybe we already have some equivalent of mesh networking in the internet as we use it today. But I want to talk briefly about what network topology, which is just a fancy way of saying the map of the network, looks like in practice. Let's say you want to communicate with your friend, and you think, okay, I'm going to communicate with my friend over the internet. Pretty straightforward. You don't connect directly to the internet to talk to your friend. You connect to your access point, your upstream router, which is a single point of failure. That router talks to the ISP, which is another single point of failure. And then the ISP talks to the internet on your behalf, talks to another ISP, your friend's ISP, which talks to their router or their upstream. And then finally, you can talk to your friend. So we started way back when, the original internet, with a sense of everything being connected. But very quickly, because we had to maintain backwards compatibility, and because we were trying to bring on more and more users onto a system that was designed for 10 universities and a couple military installations, we have all these intermediaries. Every arrow here, more or less, represents a point of failure that could be controlled by a third party or could fall over and prevent you from being able to connect to the internet to talk to your friends. Related to that, you don't have to understand this in depth. This is a map of what a packet looks like, the data that moves across the internet. And I want to highlight two things on this, which is that source address and destination address. Those are just IP address fields in certain versions of the Internet Protocol spec. But you don't ever, almost ever, directly send a message to your friend's IP address. Their IP address is rarely the full destination. That IP address has to get wrapped and translated through all of those layers that I just talked about. So you are actually sending that message to your upstream, which is then looking up how to wrap it to send it to the ISP, which is looking up how to wrap it to send it to the other ISP, and then that whole thing gets unwrapped all the way across to make it to your friend's machine to send them a message. And so we Most of the modern internet is hacks on top of, again, this basic starter system that we developed for a few universities and military installations, because the internet, one of the better things about it, has aimed for absolute backwards transparency. You can, and people have, connected computers and operating systems from 1970-something, and they can still communicate with other systems on the global internet. And that's magical, but it also means that it's like really complicated, and one of the sacrifices we've made is to have a lot of gatekeepers and single points of failure along the way. As a side note, just because I think it's interesting to talk about all of the kind of like cruft that we've built up, because part of my motivation for this talk is to inspire people to think about new ways of communicating and new ways of thinking about internet communications. This is the OSI model. Basically, nothing you interact with has ever used it. You've probably never actually used anything that used the OSI model, despite it being the official model. What you've probably used, in most cases, is the TCP/IP model, which is an homage to the OSI model. It's like loosely based on the OSI model, but it's not a one-to-one by any stretch. And I point this out to say that even where we have specs for things like the internet, we don't follow them completely. I mean, the kind of canonical example here, how many people know not know, if you can quote this to me, please don't, but how many people have seen the full regex for parsing an email address? Keep your hands up if you think it's correct. Yeah, okay, great. The joke is there is an official regex for parsing an email address. It's like a full page of text, and it's wrong. It doesn't catch all email addresses. As a side note, just check for an @ sign and a dot. You'll hit 90% of cases and move on with your life. So we have all these protocols that we've developed on top of this stack that kind of loosely map between these things. But again, the internet as it exists today has 42 layers of cruft on top of what was supposed to be a very simple protocol. And to call back, if you're an ISP, you actually have mesh networking. You are connecting to all of the other providers in some configuration, and if one of those goes down, you can reroute, and you have multiple hosts and multiple domain name providers, and you can make a connection, and you can transparently use the mesh, but that transparency is not actually available to the end user. You are throttled, you are bottlenecked by the ISP, which is taking advantage of this massive internet backbone. And so, another thing that's changed from the original internet to now is we are mostly connecting to the internet wirelessly. I'm sure many of us still have wired connections to our desktops at home, but I bet most of us have those for like the servers we use for doing massive data transfer, and 95% of our personal, internet usage is through a radio device of some description. And so radio is going to be kind of the future of how we build mesh networking, because if you think about it, if you're trying to build a mesh network where multiple nodes can connect to other nodes, you don't want to be running wires between every node. That gets messy fast. We're going to use radio. And specifically, we're going to use a radio system called LoRa. LoRa is an incredible acronym. It stands for long range. You can see where they got the name. And it sits in this really interesting space where you can kind of compare it between cellular, which many of us are familiar with, and Wi-Fi or Bluetooth, which sits in a different space. And so you can kind of see here that it sits below those in terms of bandwidth, and we'll get into that. But in terms of range, I think the current range test for a LoRa network is something like 815 kilometers, right? Like point-to-point node, we're talking huge ranges, but that's going to come at a bandwidth cost, and we'll get to that. It's very low power, which is good. You can run these things off small solar cells and set up stations that require, in some cases, less power than a comparable ham radio. If you're familiar with ham radio, LoRa is normally lower power than a lot of ham radio installations, and it's using. This is going to be a very technical term. I'm not going to get too deep into the radio side, but come talk to me after. It's using license-free sub-gigahertz bands. Most of your devices are using unlicensed radio bands because the FCC in every country on Earth, basically, that has some sort of radio governing body, has taken the full bandwidth of everything you can broadcast over radio and sliced it and regulated it. Most of the things that you're going to do are on unlicensed sub-gigahertz bands, but most of the things that are in your pockets have had like a full verification process where they've said like, hey, this radio absolutely cannot go outside the Wi-Fi spec or outside the Bluetooth spec. LoRa is kind of a little bit more Wild Westy, but the upshot is you don't need any special training or any special licensing to use LoRa bands. And it is available in every country with some slight frequency twists. LoRa is just the radio, right? So it is barely software. If you think about it, it is the Ethernet card. It is the Wi-Fi card. It is not actually the stack that does the networking. It's based off something called chirp spread spectrum radio communication. This is an image that represents it. I'm not going to go deep into that. It's not required for understanding how this works or for using the system. Again, we can talk about this afterwards if that's interesting to you. What is interesting is the networking stack, and that's Meshtastic. Meshtastic does some pretty simple things. It provides the networking stack and the kind of routing protocols on top of LoRa. However, if we go back to this image here, longer range means less bandwidth. So some of you are going to be very familiar with the number 4.7 gigabytes because that indicates you've done something with media in the past. If you were to, at the absolute maximum of sending data over LoRa, at 4.7 gigabytes, it would take you 8 days to transfer what is effectively a DVD. So this is not at the point where we can be replacing Netflix with Meshtastic, but for text communication, text is pretty small, text is pretty cheap, it's definitely doable. And so talk a little bit about how that works. Let's start with a direct message. This is me talking to another node, and if I, note a couple things to notice here, that little encrypted sign, most Meshtastic communications are using AES cryptography, where you have a public and a private key and the other nodes on the network have a public and a private key. It is not a signal replacement. It is not perfect forward secrecy. They are working on fixing some of these things, but for right now, it's kind of a base level of encryption such that it's, you can't just like snoop most messages off the wire, but it is vulnerable to some attacks that, something like Signal is not vulnerable to. Okay, in terms of how it works, if my phone is trying to send a message to the node on this computer over here, it's going to transit through other nodes, and these nodes are going to pass the message along because it's a mesh. I know that this computer node exists, and so I'm able to target it directly, and it moves along the mesh, and then an ACK is sent back saying like, okay, great, that message was received, it's been acknowledged, it hasn't just been lost in the ether. So DMs are powerful, you need those for a messaging network. Kind of more powerful from the Meshtastic point of view is channels. Channels are basically a channel name and a key. And if you set up Meshtastic for the first time, your default channel is going to be this one. You notice the key is blank. This one is like there's kind of a global public channel, and this one is snoopable because it's just a blank key, right? The channels have their own specific key on top of the personal device key, and so anybody can see anything that's posted into the public channel. Now, a thing that we should talk about is if we go back to this image, if you move out of this set of mesh, then the channel is you only see the messages that you see, I hope that makes sense, right? Like if I send a message to the public channel and your device is not in range of any part of the mesh at all, you are never going to receive that message. There's currently no backfill on messages. Again, it's early days, this is something they're working on. Now I have to go forward. Okay, so this is me posting to a public channel. I happen to live in Alameda, and this is where we get into the kind of power of Meshtastic channels, which is also extremely complicated. So buckle up, this one's going to be fun. So this is a computer device, a computer node, sending a message to the channel, testing from Alameda. It's the public channel, everybody can see it. So the first thing it does is it sends it to the neighbors it knows about. This is the first send. This is not a hop, that's why it's labeled 0. Those neighbors are going to send the message on to their neighbors. Now, a couple things to note here. So this is one hop because you've gone past one node to the neighbors of the neighbors. When you send a message to a channel on Meshtastic, you never receive an explicit ACK like you receive in a direct message. Instead, every node that receives it broadcasts its back, and you getting the broadcast back is the acknowledgement that the network has received your message. And so that's why this is one, right? It's sending it to all its neighbors, including the one that it sent from, right? It's message flooding, but slightly smart message flooding. It's just kind of, whenever you receive a message on a channel, send it to everybody who knows about it. Then those neighbors are going to send it to their neighbors. This is the second hop. And you'll notice that, like, if you've already seen the message, you're not going to forward it on again, which is why there isn't a, like, 2 coming from this one over here. Can you even see that? No? Okay, fine. If you look at the computer, there's no, like, 2 coming off of it because it's already seen that message. It's not going to forward on something it already knows about. And then we get to the third hop, and most Meshtastic clients are configured to kill a message after 3 hops. And so at the end of this third hop, not only has every network in the every node in the mesh seen the message, but it's run out of hops. If you're familiar with traditional TCP/IP networking, hops you can think of as like time to live, right? You send a ping with a certain number of nodes that it's supposed to hit before it just dies. The default for most Meshtastic clients is 3 hops, and then the message doesn't get forwarded on anymore. This is very important because if it was much higher, one of the complaints against Meshtastic is that this message flooding protocol can create a lot of extra traffic. If this were higher, it could, really start flooding the network in a negative way with way too many messages. Okay, that's basically everything we're going to talk about in terms of how Meshtastic works. Now we're going to talk about how you use it. It's a wireless protocol, and it needs at least 1 and up to 3 antennas. You need a LoRa antenna somewhere. You probably also need a Bluetooth or a Wi-Fi antenna so that you can talk from the LoRa antenna back to the device that you're actually communicating with. And one of the cool things about Meshtastic and LoRa devices is they do support doing location via GPS, so you might need a GPS antenna. Anyways, I just also really love this tweet. Please enjoy. You are going to need a device of some description. They range the gamut from, cheap and you have to do a lot of the work yourself, all the way up to complete, out-of-the-box solution. Just to kind of talk about what's on here, because I think it's helpful to know. In the top left is a Heltec unit. That's kind of the base level starter unit that I basically recommend everybody start with. It has the job done. You put the firmware on it. It's got a little screen so you can see the messages. You're going to interact with it through a phone or some other device. The one at the bottom left is a rack device. It has no screen, but it's got a little bit more oomph, a little bit more power, and it supports better networking. The one in the kind of middle there is actually the one that I have on me right now. It's the Seed Sense Cap. And what's nice about this one is it's kind of an all-in-one. It's got the GPS and the Bluetooth and the LoRa, and it's got a little buzzer, and it's got a little button for you to respond to things all in one package. So you don't have to do any messing about with wires, and you don't have to print a case. Most of these you end up printing a case for. And then at the bottom right is kind of the most interesting, fully off-grid, no other device needed version of doing LoRa communication, which is the LilyTgo, I don't remember off the top of my head, and it's basically a BlackBerry for Meshtastic, right? It's got a screen, it's got a touch screen, it's got a full keyboard, you print a case for it, you plug in a battery, you put on an antenna, and you can basically have a full mesh networking device, no other device required, that you can use to talk on the network. Okay, once you've got a device, you're going to need to put the firmware on it if it doesn't come with the firmware already. There's a lot of, I think, kind of neat ways to do it, including if you're using a Chromium-based browser, you can, or basically a browser that supports the web serial spec, you can flash your device plugged into your computer from the web browser. I just think that's neat. But if you're not using a browser that has that capability, there's CLI clients that we'll talk about in a little bit. And then your app is going to look something like this. It's going to have a list of the nodes that you have seen, potentially every node that your LoRa node has ever seen, the ability to send DMs and channel messages, a cool little map of where every node that you currently know about was last seen, so you can kind of see like where people are, and then settings. We're going to talk a lot about settings because LoRa is high power, Meshtastic is high power, but also potentially high configuration. A thing that you might be most concerned about if you have privacy concerns is, wait a second, you said location services, you said GPS, am I revealing my location every time I use Meshtastic? The answer is, if you want to. You can turn off the location services for Meshtastic or dial them in however you want. If you want it to use your phone's GPS instead of the device GPS, you can do that. If you want to set a diameter, you can set how often it updates. So if you want people to know where you were 3 hours ago, but not right now, you can do that. It's got a lot of fine-grained controls around position, and you can also just turn it off completely, right? Like, you do not have to report a position to use Meshtastic. It's just kind of fun. Reporting a position also does not impact your participation in the network. Only the LoRa antenna is what connects you to the mesh. You do not need to report a position to use Meshtastic. But relatedly, let's talk about channels and location services. And by the way, like what I said before, a channel is just basically a name and a key. If you scan this QR code, this is actually a Pythonista's channel that I have created that now anybody who has a device can join. And so let's remember what this means. This means that the key and the channel will be saved on your device, and anytime you are in range, in mesh range of someone else who has that key saved on their device, you can communicate on this channel, right? So like this weekend, we can all use this and all see the messages. When we go home, unless you happen to live near other Pythonistas who have this code, you can send messages on that channel, and you're just going to be sending messages into the void. But for when you're in a space, like a conference space, having these sorts of shared channels is really interesting and useful because you can communicate off-grid with just the people that are there, and it's kind of ephemeral because like once you go away, there's no more communication. But the other thing you'll notice is you can change your position settings for each channel that you're part of with a lot of the same fine-grained permissions that you have over general positioning. And again, if you're out, hiking as part of a group or geocaching or at a conference and trying to find people or meet up, that's where this gets really interesting and useful is you can say, hey, for the Pythonistas channel, while I'm at North Bay Python or at PyCon, I'm going to allow for sharing my position so that way people who are part of this group can find me and we can get together and hang out. Cool. I will happily share this code with other people later, so don't worry about grabbing it right now. You can come find me later, but if you want to grab it with your phone right now, I'm in the channel. You can send me messages, and anybody else who wants to join can send me messages. One thing that's true is there isn't really the sense of a channel membership list, if that makes sense, right? Because it's just who is sending messages with that key on the mesh that you can observe. Right, so like there's maybe a historical list of everybody who's ever sent messages that you have received on that channel, but there's no way to snoop on who is currently in the channel because it's based on like who's connected to the channel with that key at the time that you're looking. Okay, let's talk about using the CLI. Part of the reason that I think Meshtastic is really neat and is interesting for this conference is 90% of the tooling is written in Python. And so if you want to get started with Meshtastic on the CLI, you can do that pretty easily by uv pip install Meshtastic and then start playing with the very full set of commands that are available. This one, just to kind of run through what this is doing, it's pointing at host localhost because on this particular node that we're looking at here, I have the LoRa device directly connected via a Raspberry Pi hat to a Raspberry Pi, and so there's no like secondary wireless communication. It's like direct serial, so it's localhost, and then get the LoRa settings. And so you can see all of my LoRa settings here, which is like, are we using a preset? Yes. What region are we in? 1, because most technology is still made with American exceptionalism, and so it's region number 1. And then you can see the hop limit that I have here, which is set on all my devices, which is like, hey, if you see a message that's hit that like third hop, receive it, but then drop it. We're not passing that on anymore. The other thing that Meshtastic provides is a web interface. If you are running the Meshtastic daemon on your computer, you can interact with most Meshtastic devices through a web client that can connect both to any serial Meshtastic device you've got plugged in. So if you've got something plugged in directly over USB, or if you're connected to a Meshtastic device on your computer via Bluetooth, you can communicate with it. Or if it's connected, like I said, via localhost, like the one that I just showed, you can actually connect to the running web application, the running HTTP application over HTTP from the client and communicate that way. And so this is actually how I communicate on the kind of second node that I have at home, is through the web interface connected to the HTTP server that's running Meshtastic. You don't need to know any of this. If it doesn't make sense, feel free to just let it wash over you. You can come talk to me later. The other thing that's true is everything that's exposed through the CLI is exposed via a Python API because it's written in Python. And so to make a very, very simple Python Meshtastic client, this is all the code you need. You're kind of defining some pub/sub subscribers and some reactions to received events, and then you're saying, hey, here is an interface that I'm talking to. In this case, it's a serial interface. And so what this code is doing is every time it receives a packet, it's just printing out, hey, received a packet. But if we want to build an autoresponder, because we want to wave hi or say something to anybody who happens to see our node going by, it's one line of code, right? In this case, it's sending potatoes. And that's truly all the code you would need to build a bot on the Meshtastic network, which is kind of neat. You can just run this on your computer, connected to a Meshtastic node in some way, and now you've got a bot that you can use. And some people are doing really interesting things where they're running the equivalent of old school BBSs off of Meshtastic, where you can send commands and fetch information and get news off of it. But there's a lot of potential here for running kind of location-based mesh networking services and bots off of Meshtastic. Okay, one thing I will note, the project needs help. This is from the README of the Meshtastic library right now. There are maintainers, but there's not kind of a core maintainer. And so if this is interesting to you at all, or you just want to get more involved, they could really use a lot of help. And I will say that the documentation, if writing code isn't where you want to start, the documentation for the Python API exists, but could use a lot of love. As a sidebar, just because I think, again, we're at a conference about Python, nominally, Chris, don't yell at me, or a conference that has a lot of Python-using attendees. We'll use that language instead. A lot of the QR codes that you've been seeing me make over the course of this talk are actually also made with a Python package called QR code, because I hate basically all of the online QR code makers, because they either add tracking or they try to charge you for it, but QR codes are free. They're just a thing you generate. So there's a Python package for making QR codes. This QR code package has a lot of options for doing it in different formats and different sizes and embedding certain things, but you can also just run it to generate QR codes. So basically every QR code in this talk was made with a Python package for generating QR codes. Okay, sidebar. So what is the mesh good for? There are a lot of limitations. There are bandwidth limitations, there are location limitations, there are security limitations. What can we do with it? And again, a lot of this is still early days. I would say that I first heard about the project probably in August of this past year, and I got a device in January of this year, and just in the past 4 months since getting a device, I have seen the network grow and grow and grow. So there's a lot of excitement around it, but it's still very early days, and we still don't know the full potential of what's going on with this project. So if you're in a place without good reception, or you don't want to use the built-in network around us, this works great. I've seen a lot of people using it for if you're going out on a hike for a place that has no reception, give everybody a Meshtastic device, and they can now communicate if they get lost or separated out in the wilderness. You can do IoT devices that you don't need a subnet of your home network, because it's not communicating over TCP/IP at all, right? They can communicate with each other via mesh, and you can send commands to your IoT devices over the mesh network. In-person event communication, like I just mentioned, a lot of, I haven't seen this as much at programming conferences so far, but a lot of hacker conferences have a big following of people using Meshtastic. So like the place that I first saw it was at DEF CON last year, where there was a big group, and I bet that this year will be an even bigger group. And also at a security conference, a hacker conference up in Seattle is where I saw it. So like, it's a growing network, and you all here today can be on the ground floor of this growing network of mesh devices. You can build your own AirTag system, but hopefully the inspiration here is like, with this, what could you do, right? Like if it's very easy to add a little device to something that can send text without needing a HTTP connection or without needing a Wi-Fi connection, what can you build with that? I'm going to dig into the building your own AirTag network. As I was packing for this trip, I couldn't find my Meshtastic device. I knew it was somewhere in my house, but I literally could not find it. This is like a bash.org quote come to life. And then I remembered that you can configure your Meshtastic devices to chirp every time you send it a message. And so because my phone was still connected via Bluetooth to this device, I turned on the chirp settings and then sent it a message and just listened around my house until I found it and could respond to the message. So wasn't intending this, but proof positive that like the AirTag totally works. You could totally build one for yourself and find things around your house with no third party involved. So like I mentioned, there are definitely limitations. Some of those limitations are fundamental to the fact that the LoRa spec has optimized for range over bandwidth, but there's nothing inherent to Meshtastic that says it has to be LoRa, right? Like LoRa is just the radio. Meshtastic is a networking stack on top of the radio. You could build a Meshtastic network that is based off of some other networking stack altogether. The other thing that's true is, I don't have a screenshot of this, unfortunately. There's different presets for how the radio talks in Meshtastic, and it's a combination of like speed and distance, if that makes sense. So like most clients are configured with long range fast, right? And that's a set of radio settings that basically say we're optimizing for range and we're optimizing for quick message send. But when you do that, you're trading off bandwidth. You can instead go for short range fast, which will decrease the spread of your messages, but gives you more bandwidth and it's still pretty quick. And so if you had enough devices doing short range fast, would probably, you'd increase your bandwidth, so you might be able to start doing things like maybe text-only HTTP pages, as an example, or you'd be able to do like much faster, much bigger message communication, probably still not images. That's a different story altogether, but you could start building more of a network with the more devices you have. There's literal network effects to mesh networking. Broadcast hops are noisy. Like you saw earlier, it floods to everything until it either runs out of hops or has already seen the message. People have complained about that. When I hear about that, I think of people who complain that something is slow. Slow is relative. Slow compared to what? Right? Like noisy compared to what? Wi-Fi is broadcasting to the whole network as well and just kind of like filtering based on what channel you're on. So like, I don't think that's as big a problem as some people are making out on the internet. There are alternatives. The biggest one right now is called Reticulum. Reticulum is less of a networking stack the way Meshtastic is, and is more a toolkit for building networking stacks. Right? So if you want to build your own mesh networking application with your own like vision for how that should work, Reticulum will provide you the tools to build that on top of LoRa. I mention it because some people are really excited about it, but obviously it's going to be a not very beginner user-friendly option. Okay, where to go from here? There's the official Meshtastic site, which has a lot of great information, especially on getting your first radio and how to configure radios and configuring antennas. Because this is a long-range radio spec, much like anybody who's done ham radio, you can spend forever trying to pick the perfect power and antenna combination. Again, the more nodes that are in your area, the less important this gets, because the shorter hops, the easier things get. If you're in the Bay Area, there's also this group called Baymesh that is running a bunch of tools and has a couple meetups and has a guide for how to get connected. They also have instructions for getting onto their MQTT server. I didn't talk about that much because it's a little bit against the spirit of the talk, because we're trying to be like totally off-grid, but there is a way to kind of connect mesh-tastic nodes over the normal internet through MQTT. Your mileage may vary. I'm going to talk quickly about some Philip things. Like I said, I'm the CEO of CrowdAlert. I'm also the founder of CivicBand. CivicBand is the spinoff from that project that I kind of first talked about here 3 years ago with pulling civic data with Python and automating that. We now have 8.7 million pages across 300 and something municipalities, and we're about to start adding election finance data. If like local government data or campaign finance data or just civic data, civic tech in general is interesting to you, please come find me because we're doing a lot of interesting work there. And then I have a small management and like coaching company called Galaxy Brain. If you find yourself in need of like either career coaching or management coaching or executive coaching, come talk to me about that as well. And I think that's it. Thank you so much. One thing I'll mention is if you find me at lunch or any of the breaks and you are at all interested in anything I just mentioned or interested in tarot, that's a kind of passion side hobby project of mine, and I'm happy to talk about tarot. I've got a deck. We can talk about like how that works as well. So thank you. Appreciate your time.